Why are subnet masks relevant for the individual computer on the network? I understand how subnet masks are used to divide a network into subnetworks, but why does every computer in the network need to know the subnet mask and not just the router? I could understand it if each computer were physically connected to each other with a wire, but all packets needs to go through the router anyway. Let's say that I have a computer on a network 192.168.0.255.255.255.0, which has the IP 192.168.0.1. If that computer tries to reach a computer outside the subnetwork, let's say 192.168.1.1, it transmits the message to the router. The router identifies that the IP is outside the subnetwork IP range, and rather than transmitting it on the subnetwork, it transmits it to the network it is connected to, perhaps another router.
Your original assumptions are not entirely correct. What you call a router is two devices in one, a two-port router internally connected to a multiple-port Ethernet switch. Here's an example diagram. This means that the computers are directly connected at layer 2 and can send packets to each other without going through the router core. They're simply relayed between ports by the switch chip. The router has its own port in the switch. So if you look at the packets using Wireshark, you'll see that they directly use each other's MAC addresses, while outside packets always have the router's MAC as the destination. I'm assuming you're talking about the typical wireless routers found in most homes, which are the usual cause of this kind of question. A bigger network would have a separate router with one port per subnet, and a few separate switches, perhaps a master 1+1 per floor/room, and several dozens of computers connected to those switches. It's roughly the same with Wi-Fi networks, except switch is replaced with wireless bridge aka access point. In both cases, connected computers can send packets directly to each other at layer 2, without going through the router. Comments. When I stated router, I did actually mean switch. My mistake. My point being, that each computer in a subnetwork is not connected to each other, but rather to a switch, which then can pass on packages to the correct destination. An Ethernet frame does not contain the subnet mask, as the switch already has this knowledge and hence does not need it to do the correct switching. That's again incorrect. Switches do not have this knowledge. Their switching core works at layer 2 and does not know anything about IP-. It forwards Ethernet frames purely based on the destination MAC address field. Therefore, hosts need the subnet mask to figure out what MAC address to use as the destination. If the peer is within the same subnet, it's assumed to be on link by definition, so the Ethernet frame will have peer's MAC as destination. For peers outside the subnet, the Ethernet frame will have the gateway's MAC as destination. This applies to the default configuration. Some special snowflake networks alter this. For example, most operating systems allow adding extra on-link routes for additional subnets. Conversely, some switches may be configured spoof ARP responses such that even on-link traffic is forced through the gateway.
How does a computer know if a destination address is in the same subnet on another? Checking the local address and the subnet mask. Let's check a couple examples. If my computer has the IP 192.168.0.1 and the mask is 255.0.0.0, it means that any address from 192.0.0.0 to 192.255.255.255 is in the same subnet. The packets to all those other computers don't need to go through the router, they can be sent directly. Send an ARP packet to get the MAC address of the destination computer and then send the packet. But, if my computer has the IP, 192.168.0.1, and the mask is 255.255.255.128, then the computers in the same subnet are from IP address 192.168.0.02, 192.168.0.127, only. They can be reached directly, send ARP, find MAC address, etc. Any other address, for example, 192.168.0.200, must be reached passing through the router.
Something non-obvious about IP is that every IP device is itself a router. This can be seen on a normal PC with the command route print. You are connected to two networks, your local Ethernet or Wi-Fi segment, and the local host network. Every packet needs to be subject to a decision as to which network to put it on. This becomes more apparent if you put your computer on two networks, say a public and private one. Now you definitely need the subnet mask in order to decide which network to send the packet on. Many people will accidentally discover that a PC with a single network connection may work with a wrongly configured submask. They just end up sending everything to the gateway.
I see this mentioned in some of the other answers here, but I think it could be clearer. On computers with multiple network interfaces, the subnet mask may be used to automatically determine which physical interface to send IP traffic on based on the destination IP address. If you're sending a packet to a device on a LAN connected to one of the interfaces, in order to know which interface to send it on, if you haven't configured a route explicitly, the computer can check the interfaces to see if subnet_mask and AMP, destination_IP equals subnet_mask and AMP, interface_IP, by an AMP, I mean bitwise, and then by equals I mean to assert equality, and if there's a match, choose that interface. That way if you've got, for example,